So now we'll discuss about that machine cycle. What do you mean by machine cycle? First of all, we need to understand. So as we know that in 8085 microprocessor, this is not having any internal memory and this is not having any input output port internally. So due to that reason, whenever this microprocessor needs to communicate outside of the world to the memory and IO, then it should interface externally to this microprocessor 8085. So here with this memory part, what it will perform the operation, this microprocessor will read the content of this memory or it will store, that is called write into this memory, as well as this microprocessor will read the status of input output port which is connected through this IO port here. This is IO port here, and at the same time like this can either read or write. Read means like knowing the status of that port, and writing means updating the status of this port. So what are the operations performed externally by this microprocessor is basically referred as machine cycle. So their proper definition is machine cycle is defined as the time required to complete one operation of either accessing memory or input output port or device or acknowledging an external request. So that will be the part of interrupt, and this machine cycle consists of 3 to 6 TST. So there are basically these 5 types of operations is performed frequently by this microprocessor 8085, which is called as a opcode fetch operation. Then second one is called as a memory read operation. Third one is called memory write operation. Fourth one is called IO read operation. Then fifth one is called IO write operation. Sixth one is called as interrupt acknowledgement. And seventh one is halt, hold and reset. So these are less frequently used in this one. But these first 5 operations is more frequently used by this microprocessor. So to complete one operation of these kind of things, how much time it is required is called here as a one machine cycle. So by this 8085 to complete one machine cycle, it is required minimum of 3 T state, minimum of 3 T state and maximum of 6 T states required for the execution of any of this operation, whatever it has given in this list. So here, whenever this microprocessor is performing these kind of operations as opcode fetch or memory read or memory write, programmer or tester can identify the status of this microprocessor by knowing or by checking the status of the signal, which is called here as a IO oblique M bar. So this is giving the indication whether microprocessor is accessing input output port or it is accessing memory. That we can easily find out by knowing the status of IO oblique M bar. Then after that, as per the status of S1 and S0, this can easily find out whether microprocessor is reading the opcode or reading that operand. And then this microprocessor will generate the control signal. So by knowing all this data, programmer can test easily what the kind of task or what the kind of operation is performed currently by this microprocessor. So for opcode fetch operation, this is basically opcode is stored into this memory part and which is read by the microprocessor for the completion of the execution of an instruction. So here it is memory related operation. Due to that reason, for this opcode fetch operation, IO oblique M bar status must be 0. Then to read this, like there are two type of reading. One is opcode reading and another one is memory reading. So how to differentiate whether it is like opcode reading or whether it is having operand reading, so that we can easily differentiate by knowing the status of this S1 and S0. So here, while performing this opcode fetch operation, the status of this S1 and S0, it must be 1 and 1. And this is memory related operation, and that is the reading operation. So their control signal will have here as a read bar. This microprocessor will either read either read the data from this memory, or this microprocessor will write this data, like it will read this data from the memory, or it will write the data inside the memory. So whenever it is reading the data from the memory, by that time control signal will be having the status as a read bar. It means if this read bar signal is having 0, then only reading operation can perform by the microprocessor with this memory. Now, for the memory reading means what? As like for example, let's say the instruction is MVI B, 07H. So here as a operand it is having 07H. So whenever, and this MVI B is giving here the hex code, which is basically the opcode. So MBI B is giving here the opcode, and 07H is the immediate data as a operand. So how to differentiate this opcode and operand with this status signal? So still this reading of the operand is read operation from the memory. This is the read operation from the memory. So this signal status as IO oblique M bar, it must be 0 only here also. And then to differentiate this reading from this opcode fetch operation, this status signal must be different compared to this 1 1. So here in this case, the status of S1 is 1 and S0 is 0. So if this kind of status is appeared across this IO oblique M bar signal S1 and S0, then we can say that microprocessor is reading the data which is called as a operand, and in this case also the control signal will be read bar only. So whenever this is the reading operation, so if this read bar signal is 0 because it is active low operation, so then only it can read the data from this memory, and that is called operand for that particular instruction. Similarly, now we have the next operation which is called as a memory write operation. So here for the memory write operation, this IO oblique M bar, still it will be 0 because it is memory related operation. So the status of this IO oblique M bar for this third machine cycle will be 0, and this S1 S0 to differentiate this from this read to write cycle, this will be having here 0 1. And this is writing. Writing means microprocessor is going to store some data into this memory. So that is called basically the write operation. So here the status of this control signal will have write bar is equal to 0 because writing operation is also active low operation. So whenever this write bar signal is 0, then only writing operation is possible from the microprocessor to the memory. Now with IO port related, the operation is IO read and IO write. So here, how will differentiate? First of all, this will differentiate it by this signal IO oblique M bar. So whenever this microprocessor is performing the operation with IO port, then by that time IO oblique M bar signal will be having here as a 0. Sorry, it should be 1. This IO oblique M bar, it should be 1, and this is only limiting for IO mapped IO. So that details you will see in that chapter again. So here this IO oblique M bar, if this signal is having 1, it means it is saying that microprocessor is busy to perform like interacting with this IO port. And here how to make it read? For the read operation it is having 1 0, so we'll make it here 1 0, then it is indicating that it is reading operation, and this one is indicating it is reading with IO port. So here by that time it is the reading operation. So again this control signal will have the status as a read bar is equal to 0. Similarly, for IO write, still it is interacting with this IO port. So this IO oblique M bar signal must be 1. And this status signal as a S1 S0, this will be just like this as a write operation 0 1 here. So here also we will get it 0 1. 0 1. And this is writing related operation. So here the control signal will have as a write bar is equal to 0. Now the next is having as a interrupt acknowledgement. So this kind of operation is basically deal whenever this microprocessor is dealing with like interrupt part, then only this kind of signals will be having that like operations is required by that term. So here as an interrupt acknowledgement, the status of this signal should be 1 because this interrupt is also similar to this IO operation. So this signal IO oblique M bar should be 1, and this S1 and S0 this should be also 1 1. So this is giving here the operation about that interrupt acknowledgement. So this IO oblique M bar S1 S0 is having the status of 1 1 1. Then this is indicating that microprocessor is performing the operation as like interrupt acknowledgement. And by that time, once the microprocessor is acknowledging that interrupt request, then this signal will be raised, and by that time the control signal raised will be INTA bar is equal to 0. And for this halt operation, this is IO oblique M bar is Z. Z means high impedance state. It means these lines through which signal is interacting from microprocessor to the outside, it is going to be into the high state during that halt operation. So here this IO oblique M bar, it should be in the high impedance state, and S1 status it is 0, S0 status it is 0, and read bar as a control signal is also in high impedance state. Similarly, for hold operation, the status of IO oblique M bar is Z, that is called high impedance state, and this is having don't care. S1 is don't care, S0 is also don't care, and the control signal here as a right bar is also in the high impedance state as a Z. For resetting, so this reset is also more frequently used. So whenever you are going to change a program to the new program, then before going to the new program, we have to reset the system, we have to reset this microprocessor chip or this module. So due to that reason, this is also used whenever we are changing a program. So by that time, this IO oblique M bar, it should have the status of high impedance state, and then this S1 and S0, it will be in the don't care state, and by this time the control signal or control status will be having INTA bar is equal to 1. So I hope you understand about this machine cycle. Means for uh, for the execution of any operations as like opcode fetch or memory read, how much time it is required. So that is referred here as a machine cycle, and this table is giving the idea about that by that time what is the status of this status signal as well as this IO oblique M bar.